Okay, I think you should see my screen. Okay, perfect. I will start presenting. Hi everyone, my name is Pavel. I am the developer relations lead at ZKM. My previous experience, I joined the space in 2017 as more so of an educator. So I taught from companies like RBC and as well as like governments about like just Ethereum and technology. So hopefully I can take some of that presentation skills and sort of make this more fun and interesting. In addition, I worked for Metis as a developer relations advocate and essentially know a lot about optimistic rollups as well. Migrating to ZK technology has also been an adventure, and I'm also a current founder of a different solution. So I'll just jump right in to everything. So I did a lot in the space, and you'll probably see me at Istanbul for Dev Connect as well if you're going. So I'll give a brief overview for ZKM, who we are. We are a universal and general purpose ZK VM based on the MIPS instruction set. Now, what does this mean, ZK VM? Essentially, MIPS is an instruction set. It is how computers communicate. It's low-level, assembly-level instruction sets. So this is basically like at a lowest level before binary, I guess, and essentially going in and computers communicating. So what we're attempting to do is going in and taking the computation from these the MIPS instruction set or applications that use the MIPS instruction set, and then use the computation from this and generate proofs that are able to prove that computation did happen. And fun fact, MIPS is a old language, or sorry, old instruction set created in 1985 and open sourced very recently, I think 2018. It's a simpler instruction set, and so that's one of the motivations for utilizing this over alternatives. So what we're doing essentially is taking some of the language or some of the operations that occur and generating proofs, submitting those proofs to Ethereum L1, and where it can be provably verified by a number of people. And this can essentially work for any type of computation. So this is where the power comes in, like why this complexity, why specifically this. So it all comes down to being able to run any form of computation on any device that uses the MIPS instruction set. So the whole entire vision, how does this translate into what does this look like? Well, we want to, as a core, turn Ethereum into a global settlement layer. So taking essentially blockchains themselves, layer 2s, and then combining that with general computation for verifiability, and then all the way from like dexes to like applications itself and on-chain applications, off-chain applications, so anything in between. So we want to make it more so of a general purpose accessible way to verify any form of computation. And I will go through some of the use cases that we're currently working on and currently developing, what you should stay tuned into. So to emphasize like what the overall landscape of all of this developments are. So we want to attract the miner community to essentially create the proofs using the ZK VM, and then essentially from these attracting other developers to come in build on top of like applications that utilize this. So, for example, we can do things that operates cross-chain transactions from different L1s. So that's something that we're looking into and working on. We can do things that involve swaps from different protocols, verified from like different chains as well. So that's sort of like the bridging, but also like additional computation, additional complexity within there. We're also looking at verifiable computation for essentially you take a piece of computation and just like running essentially that computation across different IoT devices. So splitting up into like clusters of computers, verifying different types of complex operations, breaking them down into like simple things, so that you don't run it on like a dinky MacBook at like 8 gigabytes of RAM. So in this, I'm actually gonna zoom into this slide because I think like it's a little bit zoomed out. So just to go over the overall architecture. So there's the VM basic. This is just the generic computations that occur within the virtual machine. So if I zoom in right here, so we have this right here. We have the MIPS program, and the binary file, the executable file for MIPS is called ELF. We take that file and then we run it through the VM, which then is able to produce results from that execution, so that the execution trace. From these results, we're then able to generate a Stark proof, and then use or recursively iterate using like Plunky2, and essentially generate a proof that's smaller sized that can fit on the Ethereum blockchain without actually costing like a lot in terms of the deployment for storage. So we can essentially use what already exists, put it together, and verify computations at a reduced cost using technologies like Plunky2 and Stark as well. So that is just the overview on like how the overall like operations work and how we're like condensing this and making this essentially provable in terms of just general computation. So why go through all this effort? What's the actual like practical use cases for this? Well, the first one, which will be upcoming, hopefully by the beginning of next year, Q1, where we're looking at the hybrid rollup, essentially taking optimistic rollups from the OP stack, and then the ability to essentially grab what the sequencer produces. So how this all works with optimistic rollups is that the sequencer takes in transactions. They have like an order of transactions that they then compute the state for. They submit the transactions as well as the state, and essentially there's a 7-day window where anybody can come in and say, hold on, the state doesn't match the transactions if it's executed, and then they submit like a fraud proof within that 7-day period. The downside to that is that there's a 7-day period. You have to wait in order to actually withdraw your funds. So that's obviously, for impatient people as well as like just regular everyday people, you don't want to, wait to essentially use your money. And then in this case, what we can do with ZK MIPS is we can take these individual transactions that were submitted by the proposer, by the block proposer, and essentially compute essentially ZK proof from all of this, and then we're able to essentially use the MIPS instruction set to compute the proof, send that proof over, and then the prover goes in and says, hey, well, hold on, wait, it doesn't match the results, or it doesn't match the output, so I'm actually going to submit a fraud proof and then like earn the money from there. That's the optimistic part. But let's say it does pass that verification stage, then we submit it to L1, to the smart contract, and then if everything works out, then what we can do is essentially have more so of an instant finality, or like a way to instantaneously withdraw the funds, or like semi-instantaneously. You might have to wait like a few minutes and something like that. But essentially, what we can support is the ability to leverage other existing L2s, like the optimistic rollups, and then be able to withdraw from this. And then what we can also do is that supplementing adding on to the security of L optimistic based L2s is that they have this 7-day withdrawal period. Why do they have 7 days? Well, because that's some amount of time that's like deemed to be the most secure, while also providing like some amount of time to like actively get your money out. Since you can get your money out at any time using the ZK proofs, we can actually have proving periods that are much longer than the 7-day withdrawal period. So in this case, there could be more opportunities to catch fraudulent transactions, or if someone like purchases enough processing power, not processing power now it's or like has enough stakers to like not include blocks within Ethereum, and then like manages to like block out withdrawals for like a week, even though that's probably going to cost like a lot. But you can essentially extend the security past the 7-day window, and then just have it for an indefinite period of time, or like a longer period of time. Obviously, you do want it to resolve at some point. And again, no additional complexity. So this is all can be resolved without like you needing to change like your applications to fit all of this in. Just the L2 needs to just adapt parts of their code base to this. Another use case for this, what else are we building? We want to essentially connect like the off-chain transactions together. Oh, I don't know if my screen disappeared, but essentially, or not off-chain transactions, the all other L1 transactions together. So we can connect different blockchains, separate blockchains that operate on different VM languages. So in this case, you have a Solana, you have the SVM, and then you have the Avalanche, you have AVM. And so you can essentially perform cross-chain transactions verifiably and have Ethereum be the settlement layer between all of them. So it's kind of like an L2 between blockchains. And so this is also like another like powerful part of the ZKVM implementation. And finally, like the third case, but not finally, but one of the additional examples of this is that I can actually take the different types of computation and send it to different whether it be like IoT devices, server farms, whatever, and have provable computation that the operations did take place. They're not private, but they are provable that like did they do the execution required to get to those results. So this is like another big utility for just having this provable computation at like a very adaptable instruction set. So big slide for just the review part. Essentially, we're taking in we're using MIPS instruction set to develop this generalized computation, and then you essentially can take this and develop proofs for different things. You can even take them and create your own maybe like privacy proofs using this. So we want it to be maneuverable in terms of this this set. We're making it work with all VMs. So essentially, from Move to Wasm to Rust. So having the ability to just not need to have like limitations in the language that you're building with, and instead like you can use everything to prove the computation. So in addition, like no change of the code base, right? You don't want additional complexity to like adapt all of your environments, have re-audits of everything, have re-implementations of everything, hire new developers, new people to come in and do all of this. So this is like another thing. So it's just a one thing, and then it's done. And then in addition, like how maneuverable it is, it's like, all right, well, we can have like Rust, we can have Java, we can have JavaScript, and we can like essentially prove like all of these like languages from just these using this low level instruction set. And then yeah, no need to like adapt to like constant changing standards, because EVM is still like adapting. There's different types of upgrades that are occurring. You had like different types of like gas cost changes and things. Like all of these things impact every other thing that comes before it. So you have to sort of recreate whatever it is because you have to follow along to the standards. So of course, like you don't need to worry about that. So, and then finally, it's like validating all transactions, non-blockchain and blockchain. So it's kind of like one thing for everything. So that's yeah. Here are all the socials. In addition, I do want to mention that we are launching a program specifically to reward developers participating in the ZKM ecosystem. And so we want to essentially encourage contributions, encourage ideas, encourage like basically people coming in and sharing their thoughts and their implementations of our currently released technology. We do have like a circuit that we currently released that anybody can come in and use to like prove like an Ethereum transaction or like a Goerli transaction. So you can run that. It's on our GitHub. But past that, if you join in our Discord, we will have like additional community incentives for people joining into our ecosystem, and then hopefully that can be like a leverage of like what we can do for the future. So I think my time might be up. Oh, I have to share my link to the slide. As you can see, it's dark here where I am, but I will share the link to the slide. And yeah, thank you.
Yes, thank you, Pavel, for your presentation.